Okay, so again, this first one here, go ahead and see page 29 because we did it I think we did it yesterday. All right, first one we did yesterday. All right, let's move on. The only difference with today and yesterday is just now there's more overlapping to it. Okay, more overlapping to these triangles, and it may be a little difficult for you guys to figure out what's the method of proving them congruent because they overlap so much. All right, so just like I suggested yesterday, most of you guys have colored pencils there. If you don't, there's some back on the shelf back there if you and your group need more. But go ahead, take a minute and set up this next one. And if you're waiting for us, please look at the givens and ask yourself, did I give you full sides or full angles at all from the givens? Did I give you full sides or full angles? You guys ready to roll? Okay. I gave you AX congruent to AY. Is that a full pair of sides or not? Here you go. Sorry, got to do this again. Here you go. 27. Is that a full pair of sides or not? It is. Yes, it is. That's a full pair of sides I've given you. Now, I marked it in my diagram, but it wasn't given. Are those right angles a full pair of angles? Here you go, 26. Are those right angles a full pair of angles? They're not? This angle here is not in one of the triangles? So it's a full pair of angles, right? But it's not in my given, so I need to write that they're right angles, and then I need to say that they're congruent. So step 2, how do I start by saying this whole right angle process? 16, name the right angles. Yep, CXA and BYA are right angles, yep. Reason? Now at this point in the proof, you may want to just check and see what method you're going to use, because if it's HL, you don't need to tell me the right angles are congruent. But if it's one of the other 4, we're going to have to say they're congruent. All right, so let's go do that now. I know I'm going to have the right angles, and I'm going to have AX and AY. Is this going to be HL, or is this going to be something else? That's the question we have to answer right now. Well, before we can answer that, we need to have that third pair congruent somewhere, right? So does anybody, I've exhausted all the givens, so it's on you now. We've used all the givens right now. So this is something you have to find on your own. Anything else you can see up there on your own? 19, anything on your own there? Now, when I ask on your own, that probably means one of two things. Reflexive, side or angle, or vertical angles. Do I have either one of them in these two triangles? Do they share the same full side or same full angle, or do they have vertical angles? What do we have? Great, those are vertical, but they're not in the triangles I need, right? Okay, so let's keep looking here. All right, let's keep looking. Anybody see anything they share? What do you got? Angle A. Everyone see angle A? Everyone see angle A? Is that a full angle in both triangles? Yes, it is. So we're going to count it. So I can tell you, is this going to be an HL proof? No. So let's go back to statement 3 now and say, what about the right angles? Because I'm going to need them congruent now if I'm not going to use HL. And I won't ask anybody because we just did it. The third pair comes from angle A being congruent to itself. Okay, now it comes down to, because I have two angles and a side, is this angle side angle or angle side? And it's going to be tough for some of us. I get it. It's tough for me to look at that and see if the side's in between or not. What did I suggest? Anybody remember what I suggested last week? If you're having trouble visualizing them overlapping, Ryan? Well, I have trouble visualizing that. So I'm asking, is there anything else I can do that will definitely show me it's angle side angle? Jasmine? Take one of the triangles. So I'll take BAY right here. I'll take BAY and draw it out. And I'll say to myself, what did I mark on that triangle? Well, I marked angle A. I marked AY. And I had a right angle at BYA. Now it's pretty easy for me to see that that side is clearly in between, and I can use angle side angle. Only 5 steps, but a little tough to get there if you don't see the reflexive angle or angle side angle. Anything you want to ask there? Okay, one more overlapping one, because I'm not going to beat you down with these, because I want you to try some on your own. What are the two we need to prove congruent there, Colin? GH, got it. All right. Let me start with FH congruent to GE. Did I give you a full pair of sides there? FH congruent to GE. Full pair of sides. 21, full pair of sides. Yep. Bless you. HFG and EGF. They already marked those for us, right? Yep. Full pair of angles in those triangles, yes or no? 5, yes or no? Full pair of angles. In the two triangles I need to prove congruent, are those two full angles in there? Nope. Okay, so I can't put an A next to them, but I am going to use them somehow, hopefully. Don't disregard it. I give it to you for a reason. All right, you guys ready? I've got to find 2 more pair of something. All right, 2 more pair of something. Where can I get those pairs from? Yikes. All right, here we go. Anything you see on your own. 24, anything you see on your own? Which one? Okay, that's fine. So we'll go EH. There's another side. Whew, and here's where it's going to get difficult. That third pair. Now, hey, I want you to strategize this, please. Don't just start looking at stuff, making up new theorems. See what we have right now. I got 2 S's up here. I've just narrowed those 5 reasons down to 2 now. What's the only possibilities it could be now? Side, 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 which would mean I need to try to get FE and GH congruent if possible. And what's my other option? Side, angle, side. All right, which would mean which angle now? Angle. These 2 down here, basically, right? Okay, that's all you have right now. Don't look anywhere else because we've narrowed it down to side, 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 and side, angle, side based on what we have already did. So it's either going to be GH and FE or these 2 angles down here. And remember, we have not used that given at all to our advantage. We're not giving up. We can find it. We can find it. Start with the given. Is there anything you can conclude if I gave you those 2 angles are congruent? Everything we've done so far. Sinead, let's go. Isn't that an isosceles triangle on top? And what's across from those congruent angles? Congruent sides. And that's okay if you don't know where we're going with this yet. But at least I know that FM is congruent to GM. And that's in a triangle. Congruent, I just proved what? Sides are across from congruent angles. So that gives us those 2 right there. And remember what we needed. Either these sides or these angles right there. And we're getting there. We're getting there. That was a step in the right direction by telling me those 2 sides are congruent. It's a step in the right direction. And I'll just open it up to you guys. I don't need to call on anybody randomly here. Discuss it with your group if you want. I'll give you a minute. Go ahead, discuss it. Drop some ideas off each other. Remember, it's either the sides or the angles. The sides of the angles. And I told you you're on the right path by getting FM and GM congruent. Hey, try not to prove another pair congruent. All right? Try to avoid proving another pair of triangles congruent, please. All right? I know some of you may have that idea. Not yet. Avoid trying to prove another pair congruent. Okay, I'm hearing some good stuff. Let's do the big reveal here. Where are those other pair? Ready? What did you already know at the beginning of the proof about FH and GE? These are congruent on the givens, right? And you just found these pieces. If the holes were congruent and these pieces are now, they're another pair that are congruent up here. If I take FH and do something with it with FM, is there, and the same thing with GE and GM, is there another pair up here that would be congruent? Which pair would be congruent if I did a little something? EM and MH, a little thing we like to call subtraction. Why is that so important? Hey guys, if I know that, what type of triangle do I have on the bottom? And what's across from those congruent sides? Angles that I needed for side angle side. All right, so now I'm going to turn this into subtraction. So I'm going to take GE and subtract MG and set that equal to FH and subtract FM. Then I could say by substitution that EM and MH are congruent. And that gives me, nope, that does not give me a side, but that will lead me to the angles. Angle GEH congruent to FHE. And a triangle congruent, what do we just prove? Angles are across from congruent sides. Now we have enough info because that gives me the angle I needed in side angle side. Hopefully this was a little wake-up call. Triangle GEH. Do not go ahead here. I just want to show, so I don't know if any of you were thinking about, I didn't hear it, but I don't know if some of you thought about it and maybe just didn't say it. Let's say you thought you saw the vertical angles. I know a lot of you did. You saw the vertical angles. Does this theorem work for something like this? If these angles are equal, those sides are equal. No, why not? Tell me why not. I made a big deal of this the other day. These angles are not in the same triangle, all right? They're in two different triangles, so I cannot use the theorem that says the side across are congruent. Okay, both angles need to be in the same triangle. All right? All right, here we go. I see a little nervousness in our faces. Good, good. Let's keep it going now. Go ahead. You can go to the homework now. If anything you want to go over, call me over. If you get stuck, if you want me to look over anything, but you guys know where the answer keys are.